So thank you very much again for the introduction. Thank you for giving me the opportunity to talk about my research topic. I want to talk about simple cross-lingual opinion mining, for which we provided a case study and a qualitative analysis. My name is Jared Hagerer and I'm from Technical University of Munich. Let me please give you a brief overview of my research. The goal of our research is to provide simple multilingual opinion mining, and we want to use it to investigate cross-cultural social media phenomena on social media texts, and we want to compare these between different languages and cultures. Here we investigate German and compare that with English. As methods, we use cross-lingual topic modeling, and we use multilingual sentiment analysis to be able to compare opinions between two languages, and we relate the sentiments to the topics. As evaluation, we show opinion distributions and compare these distributions with actual text examples, and we compare really the content of what we show with the opinion distributions to see if everything is coherent and correct. We want to provide two main takeaways. First, we want to provide a recipe for coherent multilingual topic modeling and opinion mining, something that you can apply for yourself then. And we want to provide illustrations that hopefully show how meaningful the results of our methods are. I start with multilingually aligned word embeddings. So that's kind of the requirement to understand that there are word embeddings. And word embeddings means that for each word we have a vector, and it means also that the word vectors from similar words, from semantically similar words, are clustered together, which is, for example, people and citizens and children, whereas on the other end we have industrially related terms. And multilingually aligned means that we have the translated words from another language which have the same or very similar embeddings also according to their translations. So we have a word embedding space that works at the same time in many languages and works in a language agnostic manner. And then there are different ways to implement that, and one way is the X-Link model, but that actually works on sentences. So it gets sentences as input, and it can be used as a black box, as it is pre-trained. It's a pre-trained deep neural network. So you feed sentences into it and you get out sentence vectors, and the sentence vectors tend to be similar when they are semantically actually similar, and that's calculated by quotient similarity. So as I said, that X-Link sentence embedding, multilingual sentence embedding framework, that's a deep neural network which is pre-trained on these tasks, which is conversational response prediction, next sentence prediction, and natural language inference. And the cross-lingual part, such that it works in a language agnostic way, is pre-trained on translation ranking. And we use it without any fine-tuning in our corpus. So how do we use it? So as I told, we calculate sentence vectors, and we do it on all sentences from our textual corpus. And then when we have these sentences, we have this sentence embedding. Also, first of all, we need to split the text into sentences, into independent sentences. Then we can generate the X-Link sentence embeddings. And then we can apply k-means clustering. Then you have different clusters. And then we can derive the cluster distribution for the whole corpus, for a part of the corpus, or for separate documents. And we can basically count how many sentences are contained in which semantic cluster. And then this is what we can use for document representation for other tasks, and also just to derive some statistics. So what I told you now is exactly this pipeline: plain text, pre-processing, chunking into sentences, applying X-Link, doing k-means, etc. Now, how do we label the topics? How do we label the clusters such that they become topics? So we derive word lists for each cluster, and that we do by a normalized TF-IDF scoring method, which shows the most relevant words for each cluster. Based on that, we can label the topics. And then we can do the aggregation with the topic distributions. And for the sentiment analysis, we use an English and a German sentiment analysis framework, a toolkit, which is already implemented and for which we can get the sentiments across for each sentence, which we can also aggregate over documents and over the whole corpus the way we need it. For the evaluation, we are, of course, interested in applying and evaluating that on our data set. So we are interested in actual opinion research for organic food consumption. And consumers of organic food tend to express their motives for consuming organic food. And the motives, amongst others, are health concerns that organic food might be more healthy than other types of food. Environmental issues play a role because organic food might damage the environment less because less chemicals are used. Certifications are necessary to guarantee a certain kind of quality, and tastes might also be positively affected, or maybe not. That might depend then on the opinion of the consumers. So how do we collect data about these? How do we collect data about these contents? So we use search terms, organic food and organic farming, and we search for these search terms on two data sources. We search on New York Times, where we have English articles, and we search also on the German translations of that in a German newspaper, online newspaper, which is called Der Spiegel. And we have around 500 to 600 newspaper articles and around 50,000 comments in total. And the time span ranges from 2007 to 2020. And this is what we are interested in. So what we see here are the topics and the topics descriptions. So here we see all salient topics. We removed around 5 garbage topics. So we have a high number of relevant and salient and coherent topics. We have the topics given in English and in German, for which we derive the top words completely separately using the same top word scoring method. And what we see is essentially that the topics have a high match. We are oftentimes, normally in all times, we see the translations of the topics of the left-hand side, also on the right-hand side. So for example, on English, in the environment topic, we have pesticides, plant, soil, fertilize, pesticides, etc. So fertilize is something that we find on the right-hand side also. Dünger, pesticides is Pestizid in German, plants are Pflanze. So we have a high correspondence here, and that also continues for the other topics. For example, for retailers, that's all about shopping and where you can go to buy actual organic products. We have store, whole, which is for whole food, which is an organic supermarket chain with shops, groceries, supermarket, etc. And in German, we have the German counterparts, which is very known, Aldi, Supermarkt, etc. Markt for market. So one takeaway is that we have a high correspondence, and what we also hope that that this is apparent is that the top words are quite coherent, and that's remarkable because the embedding technique that we use here is not trained and also not fine-tuned on our own corpus. So we just use the sentence embeddings as they come out from the deep pre-trained neural network, and still we get very coherent topics as we see here. So what we did is we applied k-means as we told before, and we did it using different k's. We did it with k 5, 10, 15, and 20, so always different numbers of clusters. And we wanted to see if there's some consistency independently of which numbers of clusters and topics you use. And what we see is that there's a hierarchical structure which is inherent to the clustering and also inherent in XLink. So we see that there are many fine-grained topics with a high number of clusters, and these are very much contained in the original, very coarse topic. And they are all very consistent. For example, we see that not only retailer stays in their own topic, which is coherent in itself, but also food prices and quality, which is also contained in the retailer's prices and quality topic, which is rather wide and related to the shopping experiences. Similarly, we see that on the other parts, even with garbage topics, which has mostly incoherent noise, they stay amongst each other and mostly do not go too much into the other topics. It doesn't mix too much. And when it does, then it probably does it in a very salient way. So we demonstrate here one use case, how you can use our topic modeling method. For example, we have the distribution of topics. The topics are here at the circle. And we have US articles and US comments in black and German articles and German comments in gray. And you can see directly on the first spot that US articles and US comments are very dominant, for example, for food products and quality, or for health and nutrition. Especially health and nutrition, the difference is very big between US and German-speaking countries. So apparently in the realm, in the domain of organic food, health and nutrition is more important for the US-speaking people compared to the German-speaking people. German-speaking people discuss more issues related to politics and regulations. And that's the case for both articles and comments, both types. It might be especially interesting for the text miner to see when there is a difference between articles and comments, because then the commenters, which is the normal consumers and people, they sometimes do not follow the media agenda, which is, for example, the case for evidence, which is more discussed by social media and less discussed by the actual newspaper articles, for German-speaking countries at least. We apply our technique to one concrete article. So here, for example, we have an article from New York Times. The article title is "Major Grocer to Label Foods with Gene-Modified Content." So that's the article, and what we want to see is we want to show the topic distribution and the sentiment distribution of that article and see how that relates to the actual article contents. So on the right-hand side, we see the topic distributions for the document type, either article or comment. The comment is the comment section below that article. And here we have the sentiment distribution. We do not go in detail about the sentiment distribution. That is laid out in the paper. We cannot present it here due to time reasons. Let me briefly discuss some examples of the topic distribution. What we have here is we have an article which is about Major Grocer, which is basically a supermarket chain for organic food, and it is about gene-modified content. So we would expect that both is represented in the topics. And that's also what we see. We have two topics which are very much present for the articles and for the comments. GMO and organic. GMO stands for genetically modified organisms, is very much present in the articles. It's the most present topic in the articles. And also for the comments. Then the second topic should be somewhat related to groceries, and that's retailers. That's the second most dominant topic regarding to comments and articles. So we can see that the method is actually able to resemble the topics from the articles and comments correctly. However, it is not always the same. For example, what we also see, there's the health and nutrition topic that is not present in the articles, but very much present in the comments. This is actually true, and that there's a good reason for that. People are buying organic products, or better said, people maybe want to avoid genetically modified content, or people want to discuss genetically modified content in food products because they think it might or might not have an impact on health. So here we see that content in the comment sections is represented even though it is not represented in the articles, which means that sometimes the user basis does not follow the media agenda. We do the same for German. In German, I translate the title. It is ecological tests, etc., on which certificates for nutrition and organic food are really good. And we would expect that this is all about GMO and organic, which is defined by according labeling. Certification is also a part of the top word lists. And then we also have retailers. So when we take a look into the article, we see basically the same thing, that both topics are very much present in the article, which also relates to the title of the article. This is because GMO and organic is related to certification, and it's just the topic for that kind of stuff. And then we have also retailers, which in the article it is actually discussed which organic certifications they are pushing, which they are selling, and also if they have their own certifications or not. And we have again the same issue with health and nutrition, which is more discussed by the commenters and almost not discussed at all by the article. So one might question why that is the case. Some concluding remarks. So we wanted to demonstrate a simple cross-lingual topic and opinion mining model. I hope it is clear that there's almost no pre-processing at all required for our method. So only sentence chunking is necessary, nothing else. In NLP, you often have the problem that you need to do lots of pre-processing, not only remove and find lots of stop words, but also remove many spelling mistakes from social media, for example, lemmatization, stemming, and other things, and different kinds of chunkings, just to speak about some things. Nothing like that is necessary with our approach. We don't do any big model training. The only thing we do is we apply k-means. So no fine-tuning, no training that can take a long time on the whole corpus is required here. Also, we do not need to determine the language which we are analyzing, even though we are analyzing several languages at once. So we work in a completely language agnostic way, with the only exception of our sentiment analysis, for which we need a separate toolkit in English and German. However, no training required either. There are some drawbacks. Now, one big drawback is that X-Ling sentence embeddings are quite costly. They have a very high, they utilize a lot of memory and a lot of GPU power, and it takes quite long for them to be computed. To avoid that, it's possible to use multilingually aligned word vectors, and they don't have all this overhead at all, and it's very practical to use them. With respect to model coherence, I hope it was possible to see that our topics depict a hierarchical and consistent structure with increasing number of clusters and topics. We saw that the topics are multilingually coherent, even though there's hardly any pre-processing involved. And also we hope that it was possible to see that the topics resemble the actual semantics of the texts correctly, which we saw by qualitatively analyzing the contents. There are some drawbacks with respect to model coherence. So firstly, it must be noted that we do not provide a proof in terms of an objective quantitative measurement. So it would be necessary to actually apply UMass and other coherence scores to be really sure that we have a high coherence for our method. And another drawback is that the German sentiment analysis, even though we didn't say much about it, it's lacking functionality, it doesn't have any subjectivity estimation, and it has a very high variance, and the bias from the German sentiment toolkit appears also to be different than the one for the English language. In the future, we plan to apply our techniques. We want to see how that can be used for media agenda setting, which means how can we see if articles influence comments, or if maybe comments influence articles and the article selection in the long run even. Therefore, methods can be used such as Granger causality and cross-stack correlations. These can be based on the topic and sentiment distributions and based on our techniques, which we provide here. And you can, for example, apply a 2-week time window and build these distributions and see how they correlate and over which time, with which time delay they correlate with each other, which is what we are planning to do. Thank you very much for your attention, and I hope to hear your interested questions. Thank you.